want to take a look at 2 problems on your homework. Yes.
So the board says last lesson of the year, but I'm looking at that board and it says 71727.
Oh, that's so sad. That needs to change. Yeah, we're going to delete that right now.
Last lesson of the year? Like, what does that even mean?
Last year, this was the last lesson for those kids. They got done. This was their last lesson in December. A smidge, not much. Not really. We're actually kind of ahead. Because the sad thing is that was 2 years ago, not last year.
Well, the
So-
SAP is possible.
Schmeling and I were very on top of things. So, if you do look at the calendar, we're kind of bumping things over a day, so I will change that shortly, but you're going to have 6-2 today, 6-3 on Thursday. We're going to do course recommendations on Thursday as well, but we are going to do that at the end of class so the seniors can do the homework, and yeah, it's kind of boring. And then on Monday, we're going to do 6-4. 6-4 is actually not a 2-day lesson. We're going to do like whiteboard practice and like some other stuff, but we're just not going to do that review. We don't really need to. And then Tuesday is going to be Chapter 6 review, and Wednesday is going to be your test. Okay? So that stuff is basically still current. We kind of had a day built in there in case we had a snow day, but like I said, I was just shocked. I couldn't believe we actually canceled, but it is what it is. So in your homework, I want to look at the cortex. There's something that happens with them that is kind of unique. Why are you not sliding? That's, oh no. There we go. All right. So we are sitting right here, and I want to look at this problem because there's a slight difference, and it basically comes down to the square. So I'm not going to do the whole thing, but where the square is kind of matters in terms of how we solve this. So when I look at this one, my zeros are going to be 1, 0, and 4, 0. And I'm going to put little stars by them because bounces happen at those points. But what are my zeros for x squared minus 1 and x squared minus 4? Really close. It's going to be 1, -1. But this, when we factor it, or you can solve it, doesn't matter. If I factor this, though, and I factor this, it's the difference of perfect squares, so it factors to x minus 1, x plus 1. And this factors to x minus 2, x plus 2. So you could get that as well if you just solve with the square root. But so I end up with 4 zeros here, whereas the problem right next to it only has 2. Now these ones cross through every single time, but the ones over there, they're just 2 dots, and then there's bounces that happens on those 2 dots. Okay? So, is there any other homework problems that you have questions about? Anything that you would like to take a look at? So today, or yesterday, not yesterday, Monday, we dealt with this compared to y. We're going to start comparing them to numbers now, like 0 and other things. But we have to do something else first. So I'm going to go ahead and get to our lesson. And I want you to start by graphing those. And what I mean by graphing those, it's just a number line. It's just like an open or a closed circle, and it's just an arrow going like that for these. They're a little bit different. All the way back to L1. Go try it as best you can. I will throw out there that we have a little key here. So if I'm equal to something, it's a closed circle. If I'm not equal to something, open circle. So try those 3 things out to kind of get the cobwebs moving, and then we'll start talking. So the first one I did see correct for a lot of people. So they did an open circle and they went to the right. Because x is greater than. So that's all it looks like. I'm going to throw the next two up there. So the next one, we go to -3. This one's going to be a closed circle, and it is going to the left because it is less than. And then this one, please, this third one, please get really good at these, okay? So this shows up a lot. My inequalities, notice which direction they're facing. So if you see something that looks like this picture, your inequalities always face this direction. They don't change. A lot of people like to flip the inequalities around and stuff. You don't have to. It's like a mold. I could just stamp on my paper that they're going to be this, and then I would look, okay, is it going to be equal to? Yeah, this one's equal to. I'll put a line there. Then I'll just put my numbers in. But I don't actually flip those inequalities. So when we get down later on, please pay attention to that. So I got -4. Closed circle, all the way till 2, open circle, that one's done. No arrows on that one. So I always harp on you for arrows. This one does not have arrows. What we're going to be looking at today is starting points and stopping points. And we're going to do that because we're actually going to look at a new form. So we have inequality form. We use that for domain and range. We use it for other things. It's actually not the nicest form. A nicer form is interval notation, but we're going to get there. So we're going to start by just looking at a couple of these. So start, stop is really left, right. So if I'm looking at this, which is basically that, where do I start? Come on, this one's not supposed to be the difficult question of the day. Where do I start? 0, yeah. Okay, this one, I'll give you a little grace. It's a little maybe difficult, but where's this stop? Where's it going? It doesn't stop. So how do we say that mathematically with a number? I'll put air quotes on that. What number is that? Infinity. So it started at 0. It stops at infinity. Positive infinity. We do have to watch out for those. We're going to skip over this 5, and I'm going to draw a quick little picture for you. So for 3, I'm going to have 3 there. This is less than or equal to. So I'm going to have a closed circle, and it's going to the left. So if I'm starting on the left-hand side, where does that start? -3 we're going to use, but it's not the starting point. Or, sorry, not -3. We're not going to use. +3 we're going to use. What's over here? It keeps going, right? So negative infinity is our starting point.
What?
Mind blown right there. So it starts at negative infinity. That's the furthest point to the left. And then the furthest point to the right, our stopping point is going to be 3. So let's do the -2. So I got -2 here, and x is less than that. So I got an open circle. It's going to the left. So what's it going to be this time? Negative infinity all the way to, where's it stop? -2. So just looking at these pictures are going to help. So keep drawing those pictures out. You can do it mentally or you can do it on your paper. And then this last one I will draw. So I got 3, I got 8, closed circles on each of them. Where do I start? Where do I stop? 3 and then 8. So here's the deal. When we do interval notation, you basically ask yourself, what's my starting point? What is my stopping point? If you can answer those 2 questions, you can do interval notation, no problem. So I'm going to go to the next slide. And so I just drew the picture for this. I'll draw it again though. So I got 3 and 8, closed circles on both. And so we said What's my starting point? 3. What's my stopping point? 8. So interval notation, I use brackets and parentheses, and it comes down to this. If I'm equal to, it's a bracket. If I'm not equal to, it's a parenthesis. So it's pretty dang easy here. So I started at 3. Am I equal to 3? Yes. So I do a bracket. I go till 8. Am I equal to 8? Yes. So I bracket. So these two things are actually saying the same exact thing. So like when I do an answer, if I'm being asked for an interval or domain or range or things like that, I tend to actually write my answers in interval notation. I don't necessarily do inequality notation. Interval tends to be easier and quicker. So I'm not going to draw the picture for the one directly below it. What's my starting point for that next one? -2. Do I put a bracket or a parenthesis on it? Bracket, because we're equal. And then my stopping point is 5. And do I put a bracket or parenthesis? Parenthesis is good. So now we're going to do a little bit of drawing here. So for x is greater than 3, it looks like that. That's my picture. What is my starting point here? 3. Am I equal to it? No, so I'm going to do a parenthesis. Where does it go to? Infinity. So notice that what we just did before, the starting and the stopping, is really the exact same thing we're doing now. We're just adding parentheses and brackets. And the thing that I'll say is infinity, are you ever equal to infinity? No. Never. So for our purposes, we're never going to, and so we have a parenthesis. So you're going to always have a parenthesis if you have infinity. If you put a bracket there, I cry slightly for you, but I will take off a point for each bracket you put down with an infinity symbol. Without fail. So we got that. I'm going to skip this one. We're going to go to this bottom one. So this is an OR. So I have x is less than -5. And I have or x is greater than 6. So it looks like that. So let's talk about this. Where do I start? -infinity is my start, and then I'm going to stop at -5. There's a gap here, so we're talking about that gap. So I put -infinity all the way till -5, and then to show that there's a gap, to show that there's a break, I put a U there. Now it's not a true U. It does not have the little thing coming on the bottom. It is a symbol, okay? So that's what we got. And then I go ahead and I put down another parenthesis, and I'm going to put 6 down because that's my start and my stop. And so I'll even label that. So this is start, stop, and then start, stop. And so I have 6 and then all the way to infinity. And so this symbol right there represents 4. So I can go back and forth. I could give you this and ask you to translate it to inequality notation, and this becomes an OR statement. So that's what's going on there. Questions? All right, we're going to get rid of all these words. We're going to come back to it though, so I need you to keep that graph. So I'm going to go to the problem that you have that is in the middle, okay? So right here, I have a function, and I look at that function and I go, okay, I'm looking at this function compared to 0. How does this function compare to 0? How is this function compared to 0? Greater than, less than? Greater than. So what that means is you actually treat them as 2 separate functions. You're looking at them almost like my function on the left-hand side, versus this is basically just like a horizontal line coming across. And it's saying, when is this function above 0? So when is it above 0? It's above 0 from here to there, and then from here, and it keeps going. You can almost see the picture that's going on there. Now, this does not say equal to. So this would be like an open circle and an open circle. This would also be an open circle, because at -3, it is equal to 0. At -1, it is equal to 0. At 2, it's equal to 0. So I don't want it to be equal to 0, so I put an open circle. So that's like what I'm picturing. But now we're going to just answer some questions. So if I have an input of -4, that's basically saying x is -4, does that give me a positive or a negative output? So basically, is your height positive or negative? So at -4, I look over here. -4 is right here. Where's my function? My function's way the heck down here somewhere. So is it positive or negative? Negative. So I'm going to circle negative. I'm going to give you about a minute to look at the rest of these. Would an input of -2 be positive or negative? Circle, go to the next, go to the next, go to the next. Or actually, I'll pick one of you, and then you're going to answer, and then you're going to pass the baton to someone else. So be ready. The nice thing is you got a 50% chance of being right. Nope.
I want to get this wrong.
We'll go through them. It's all up to you. Maybe we're starting.
I don't understand that word.
I don't know if I'm right, but I feel like
I don't understand how this works. All you did was drum. You do it every day.
I think it was negative positive.
Tired.
Negative
Coffee. Is that coffee?
negative positive, negative.
Yeah. So you don't know what that is.
Yeah. I don't know. Because the function is above. Function is above.
All right,
I think I'm right.
Gabe. You're starting us off, my man. -2. Positive or negative?
Positive output.
Look at you go. Look at you go.
Bro, I told you, man.
So, let's just, really quick. -2, where's the function? The function's up here. So that's a positive function. So that's a positive output. Okay? That's good. Gabe, you get to choose.
So explain that to me.
Yo, I'm right.
All right.
Alright, 0.
0, positive or negative? Negative. All right, that checks out because at 0, I look for my function. My function is not up here. It is down below. So it's down here, so it's a negative. All right, Julian? All right.
Negative.
So 1 is negative because I look at 1, it's way down there. All right, choose the next. Last one.
Dooms.
Okay, at 3, we look over at 3. The function is positive. So we're good to go there. So we are actually going to write this in inequality and interval form. So we're going to put down our solutions. So I'm looking here and I'm looking for positive ones. All of these should not show up when I'm done. So we're going to kind of use that as a check later on. So I am going to start with interval notation. Where does my interval start? It starts at, where does it start? The positive numbers, where do they start? Yeah, they start at -3, so they start going up. Now, -3 is 0, so I'm not equal to -3, so I'm going to put a bracket. Then, where do they stop being positive and flip to being negative? Where does that happen? -1, so this was my start, this is my stop. I'm going to put a U, because I have a gap. Now, I start again, and I'm going to start at 2. I'm using parentheses because I'm not equal. But then where the heck does that stop at? infinity. Good. So this is my interval notation. Now I'm going to translate it. I'm going to translate this one for you. And so this one is going to be my start is -3. My stop is -1. I'm going to put or down. And then I'm going to put some stuff in here. So my inequality, I'm not equal to anything. So I'm going to put two things that are not equal to. That's representing the parentheses. And then x is stuck in the middle. My inequalities are always facing this way. So please don't screw that up. When I have something like this, it always translates that. Now I got or, so x is going to be, how would I say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all those numbers. How would I say that with an inequality? X is less than or greater than? Greater than. So if I'm representing this, this gets represented by x is greater than 2. So these two things are the exact same. They are different ways of writing them.
We got the right goal.
Yes. Questions? Any questions? All right. We're actually going to go down then to the last problem. We might come back. We might not. So this is going to look more of what your homework is going to look like. So I'm actually going to cross this off because I want it to look more similar to your homework. Your homework is going to look like this. It's going to be a problem. It's going to be right answer an inequality, and then it's going to say write an interval. I actually don't do it in that order. I always start with the interval, and then I go to the inequality. It doesn't matter. You can do what you want. But this problem says the function is what compared to 0? Less than. So I'm going to be looking here. So here's 0. Less than is above or below? Below. So I'm looking here to here, and then here all the way over to there. Now this is a weird thing. 0, 0. Am I equal to 0? No. So actually I'm going to have a break there. So this is how it looks. What do I start with? What's the furthest on the left? -2. And then I get to this point, and this one's kind of confusing because it's like not increasing, but it's not decreasing. And this is in terms of the positives or the negatives. It's not positive, but it's not negative. It's 0, but that's not something that works for us. So we actually stop at 0. And then I have to make a connection. So in front of 0, we stop. And then after 0, we continue. So 0 is my start in parentheses. And where's that stop? 4. Now, I see this. I see parentheses, and I see how I have a starting point and a stopping point that's not infinity. I'm actually going to just write this out. I'm going to write x, then I'm going to put this, then I'm going to put or, and then I'm going to do the same thing. And then I'm going to fill those in. So you go ahead, you try to fill them in. See what numbers, if you can get them to go where they're supposed to go. There's a line there. Yep. All right, left to right. What are the numbers? Should be quick. I was right about to write 4. What do we think? Do we want 4 or do we want infinity?
4 because of the
In one match, so let's talk about that. In one match, they do have to match because they are the same thing. So they would not match, so there is something there. If I go to infinity, this is going above. So I can't go to infinity. So I'm going to go to 4. And what I want to point out to you, when you have these things, they shoot off, they connect. Okay? So notice the similarities. These parentheses are really giving me those inequalities. Those parentheses came from that original inequality. I basically look at that and say, is it equal to or is it not equal to? And so that's what I'm really going for. I'm not going to go back up and do that first example. We're going to go past that and we're fine. But do we have any questions? Say that again? So that's the thing. So it is going up. And here, it's also going up. But are these positive y's or negative y's? They're negative y's. And here it says we have to be less than 0. So here it switches. Now I don't have negative y's. Now I have positive ones. So positive ones we don't accept. That's why it's 4. At 4 it switches from being negative numbers to positive numbers. It's a good question. Any other questions? Yeah.
So it feels like equal to, how would that be?
So let's say that's good as well. If that was equal to, this problem doesn't change a ton. I would actually just put brackets, -2, 0, because I'm allowed to equal 0 at that point. Okay? But I'm actually going to come back to this previous problem. And so if I was equal to here, if I make that equal to, I would change this to be a bracket, and I would change this to be a bracket, and I would change this to be a bracket. That doesn't change. That's still infinity with the parentheses. Okay? So if you're not equal to something, you're pretty much always, typically have all parentheses. If you go to equal, most of the time you do get brackets, but it's okay to actually have a parenthesis because of infinity or negative infinity, if it shows up in your answer. Also a very good question. Any other questions? All right. Today is hopefully a day you have no homework leaving class. Okay? So your assignment is pretty short. It's 1 page. It is switching forms between inequality and interval notation, and then it's 2 graphs that you have to put the intervals down for. So please keep going on that. If you do have questions, please ask, because I really, truly do not want you having homework tonight. I want you to be done, and then you can focus on the next thing